As you know, of course, humans are going back to the moon. They're going to be landing by 2024 or later than that. But one of the big things this time is to go there and to go there to stay. And to stay, they're going to need local resources. And the top resource that we can all use is water. You can use it to drink, you can use it to breathe, and most importantly, you can use it for propellant. And astronomers think that there's a ton of water in the moon's permanently shadowed south poles. The question is, how do you see something that is dark and extremely cold? How do you explore that? And that's what this episode's all about. When you're out in space, water is the most precious resource you can get your hands on. It can be used for air, water, to grow food, radiation shielding, and most importantly, as the propellant for your spacecraft. Exploration of the moon has revealed that there's a tremendous amount of water ice locked into the regolith, but it's probably very difficult to access. But there are also permanently shadowed craters at the moon's poles that could have more than enough water to support a permanently inhabited station on the moon. But it's going to be tricky to get at, considering the fact that temperatures in the shadows plunge to negative 240 degrees Celsius, just 30 degrees above absolute zero. Just over a decade ago, India's Chandrayaan mission entered lunar orbit with the goal of completely scanning the surface over the course of 2 years. In 2008, the spacecraft released an impactor that smashed into the moon's south pole, releasing a plume of regolith into space. The spacecraft analyzed the composition of the plume and detected water ice. At the same time, NASA's Moon Mineralogy Mapper instrument on board Chandrayaan also detected the presence of water ice across the surface of the moon and concentrated towards its poles. This was surprising, but it was believed that the inner solar system should be largely dry. The radiation and the sun's solar wind should be sublimating away any water ice into space. While the rest of the moon experiences blazing days and then frigid nights over the 29-day lunar day, these crater floors have never seen the sun, and it's believed that these craters are cold traps which have been accumulating water and other molecules for billions of years. They could come from water-rich comets and asteroids impacting the lunar surface, throwing debris into orbit, and a fraction of which snows into these craters. And any water down there could be permanently frozen as hard as a rock, ready to be mined by future astronauts. Here's how the world space agencies plan to explore it. The first and only mission to visit this region is China's Chang'e 4 lander, which touched down at the moon's south pole in January 2019. Located on the moon's far side, the lander deployed the Yutu-2 rover, which crawled around the surface of the moon studying the environment. Over the course of its year and a half on the moon, the rover has driven hundreds of meters, photographing rock and studying the layers of regolith with ground-penetrating radar. Every 2 weeks, the mission goes into sleep mode, surviving the brutal lunar night, waiting for the sun to return so it can go to work again. But the rover didn't dare crawl into the permanently shadowed craters. In order to understand them better, NASA recently announced the plans for its new lunar flashlight mission. This is a briefcase-sized CubeSat mission that will probably fly to the moon in the next couple of years as part of a series of science and commercial missions heading to the moon. Over the course of 2 months, the spacecraft will follow an orbit that takes it over the lunar south pole again and again. It will be equipped with 4 separate lasers that shine at different near-infrared frequencies and will beam this laser light into the permanently shadowed craters. The spacecraft will examine the light returning from the surface of the moon as it bounces off the crater floor. If it's highly reflected and bounces back up, that means it's hitting bare rock. If it's absorbed, that means water ice, and the better the absorption, the more widespread the ice is at the surface. Each laser will fire for a couple of milliseconds in sequence, and the illuminated region will be about 35 meters in diameter. And so, over time, the lunar flashlight will help build up a detailed map of the quantity and locations of water ice deposits on the moon. Once scientists know where the water ice is, they're going to want to explore it close up with a rover But this has its own set of challenges, which we'll talk about in a second. But first, I'd like to thank Mike Kohler, Chris Baker, Megan Wheeler, Alan Ryder, Nishant Ravur, and the rest of our 853 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. With detailed maps of water ice deposits on the moon, the next step is to sample them directly. Drill into them, analyze their chemicals, find out how useful they'll be for thirsty astronauts. And that means a rover. But a rover working in these permanently shadowed craters will be unable to use any kind of solar electricity, which it will need to power its instruments, rove around, and keep itself warm enough to operate. The normal solution for this environment is to use a nuclear-based radioisotope thermoelectric generator, like what's on board NASA's Curiosity rover. The problem is that the rover will need to get close to the ices that it's trying to study. And if it's generating tons of heat, that's bad for the ice. So how do you power a rover in the dark without a nuclear battery? The answer should be obvious. Lasers. The answer is always lasers. The European Space Agency recently announced funding plans for a laser-powered rover that would receive a constant beam of energy from a nearby lander, giving it all the energy it needs to carry out science in the eternal darkness. The mission would involve a lander and a rover. The lander sits down on one of the nearby mountains, which are in permanent sunlight, and it uses its solar panels to generate electricity. It then fires a laser at the rover up to a distance of 15 kilometers, hitting a modified version of a solar panel, which converts this laser light to energy for the rover. The rover would be able to crawl down a 10-degree slope to the crater floor, always remaining within a direct line of sight of the lander. In addition, this laser can be used as a two-way communication system. The lander can transmit instructions to the rover while sending it power. And then the rover can modulate a retroreflector on the collection panel to reflect the laser light back to the lander and transmit data. And then the lander would relay its discoveries back to Earth. ESA engineers have already carried out a series of tests, including operating a rover in the darkness through moon-like terrain in Tenerife. The next steps would be prototypes and testing of actual hardware that could fly to the moon in an upcoming mission. We're fortunate to have a large moon so close to Earth. It's a stepping stone to help us explore the rest of the solar system. And now we're learning that there could be vast reserves of propellant sitting on the surface, ready for us to take advantage for future missions. It's time to enter the darkness and search for water. What do you think? Let me know your thoughts in the comments. Here are the names of the patrons who support us at the $10 level and more. Want to see your name here? Support the work we do? Go to patreon.com/universetoday. Once a week, I gather up all my space news into a single email newsletter and I send it out. It's got pictures, brief highlights about the story, and links you can find out more. Go to universetoday.com/newsletter to sign up. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts, and I'll put a link in the show notes. These missions will help future explorers access the water on the moon for fuel, water, and atmosphere. But what will human missions to the moon look like? Here's a video that talks all about that.